Today's lesson is called Separation of Variables. We have 2 pages of notes, so you can watch one, digest it, and then try the next one. Our goal today is to actually find the differential equation that belongs with the derivative. Okay, last class, we were given something like this, and we made a slope field to give us an idea what it was. Today, we're going to learn how to do it algebraically. Okay, so differential, we use slope fields or Euler's method, that's BC, remember. And you rewrite your equation so there's one variable on each side of the equation. So you can treat this as dy and dx are separate variables. I'm going to multiply both sides by y, and I'm going to multiply both sides by dx. So I have y's on this side and x's on that side. This one, you're going to divide, so it's 1 over 1 minus n dn equals c squared dz. Be careful on that. Make sure you have 1 over. Your turn to separate them. I'm going to leave the t squared there, so be careful on this one. You're dividing by 1 over 3y. And so 1 over t squared is still in the denominator, dt. Okay? So the goal today is you're going to separate your variables first. Okay, separate the variables. Then you want to integrate both sides. You're going to apply the initial conditions. If given, and add c to the integration line. Evaluate and solve for y, which is the function. Check the solution contains the initial conditions. And add domain restrictions if necessary. Okay? All right, so here's your problem. We're going to separate them, which is what we already did. So you have y dy equals 2 dx. And now you're supposed to integrate both sides. The integration of y is y squared over 2 equals 2x plus c. You only need one c. All right? Now you go through and you multiply by 2. And you get 4x plus c. You don't have to multiply the c. When you add initial conditions, you'll understand. And now you take the square root. Because we don't know the initial conditions, you need the plus or minus in front of this one. And we've now found the equation. Okay? This is more of the same. Y dy equals 2x dx. Integrate y squared over 2. Equals x squared plus c. So y squared equals 2x squared plus c. Take the square root. So those are pretty much both the same. Okay? Now we gave us one with initial conditions. So the first thing you do is separate them. So I've got y dy equals x dx. Integrate y squared over 2 equals x squared over 2 plus c. Now, solve for c. So I plug in my initial conditions. At 0, that's negative 2, so you get 4 over 2 equals c. So c is equal to 2. Y squared over 2 equals x squared over 2 plus 2. Multiply both sides by 2. I've got y squared equals x squared plus 4. And now I take the square root. When I take the square root, it's negative this time. That's major important, okay, because the answer here is negative. All right, so this is really important. Pay attention to the initial condition they gave you, and it was negative, so that has to be negative. Okay? So, and we get to practice one more time. So 2y dy equals 3x squared plus 1 dx. Integrate. This ends up being y squared equals x cubed plus x plus c. Solve for c. So you plug in 1 and 4, so you get 16 equals 1 and 1 is 2 plus c. So c is equal to 14. Now you have y squared equals x cubed plus x plus 14, and you take the square root, and this time it's a positive root. You don't need the positive, but I write it down today so that you all realize that it's important to pay attention to that. Oh, that should say 14. All right? So far, the integration's not too hard. We want you to get the technique down so you know how to answer them. All right? Solve the differential equation when y is 2 and x equals -5. Y dy equals x minus 3 dx. Integrate. Y squared over 2 equals x squared over 2 minus 3x plus c. Solve for y. So I get 25 over 2. 25 over 2 equals 2 minus 6 plus c. So that's -4. All right, so I'm going to add 4 to that side. So that's the same as adding 8 halves. So you get c equals 33 halves. So now y squared over 2 equals x squared over 2 minus 3x plus 33 over 2. Multiply both sides by 2. Get x squared minus 6x plus 33. And then since this is negative, this is the negative root. Not too bad. We got that. All right. This one's a little different. Consider the differential equation. 2y minus 4x. Find the value of b for which y is equal to 2x plus b is a solution to the given equation. Well, if this is the derivative, I want to take the derivative of that. So I get y prime is equal to 2. I can replace that. So now I have 2 equals 2y minus 4x. Since y is equal to this, I'm going to substitute that in. 2 equals 2 times 2x plus b minus 4x. So 2 equals 4x plus 2b minus 4x. These guys go away. And I have 2 equals 2b, so b is equal to 1. Same thing here. Find y prime. Y prime equals 5. So now I have 5 equals 4y minus 20x. 5 equals 4 times 5x plus b. 5 equals 20x plus 4. B minus 20x. Guess what? They cross out again. So b is equal to 5/4. Last problem on this page. I'm going to separate my variables. Actually, that's okay. Yeah, 4y squared dy equals x squared minus 8 dx. Integrate. This is 4y cubed over 3 equals x cubed over 3 minus 8x plus c. So I get 4y cubed. When I multiply by 3, it's x cubed minus 24x plus c. You don't have to multiply the c, remember? And then you divide by 4. Minus 6x plus c. And you take the cube root. So d is your answer. And that's all there is to day 1. Pretty basic. Come back for day 2. It gets more complicated.